Welcome back, students. So, in this video we will discuss the Textback exercises. First one, suppose you are in a dark room, can you see objects in the room? Can you see objects outside the room? If you are in a dark room, we can't see objects in the dark room. We can see the objects outside the room because out of the room light is available and rays of light enter our eyes after reflection from the object. So, if you are in a dark room, inside the room we will not be able to see objects, but outside the room we will be able to see objects. Then differentiate between, second question, differentiate between regular and diffused reflection. Does diffused reflection means a failure of the laws of reflection? So, regular and irregular reflection I explained it later and I explained earlier. Then whether it represents a failure of the laws of reflection? No. Diffused refraction does not mean the failure of the laws of reflection. Then third one, mention against each of the following whether regular or diffused reflection will take place when a beam of light strikes. Justify your answer in each case. Polished wooden table, regular reflection because the surface is smooth one. Okay. Second one, chalk powder, diffused reflection, the surface is rough. So, for regular reflection the surface should be smooth one, for diffused one the surface should be rough. Then cardboard surface, diffused reflection because the surface is rough. Marble floor with water spread over it, regular reflection because the surface is smooth one. Mirror, smooth surface, so regular reflection. A piece of paper, diffused reflection. So, if the surface is smooth, then it is regular reflection, and if the surface is rough, then it is irregular or diffused reflection. Then state the laws of reflection. Angle of incidence is equal to angle of reflection. The incident ray, reflected ray and the normal at the point of incidence should lie in the same plane. Then describe an activity to show that the incident ray, reflected ray and the normal at the point of incidence should lie in the same plane. Okay. So, that the diagram is there in the textbook. We will draw the diagram of the incident ray, reflected ray and the normal at the point of incidence. Okay. So, here it is an activity, so we need to write it like this: materials required, procedure and conclusion. So, what all things we need? Plane mirror and a ray box. Ray box means from that ray box light will be emitted. Okay, light will emit from that ray box. So, fix a sheet of white paper a little beyond the edge of a board. Place a plane mirror strip vertically to the paper using a stand. Throw light from the ray box on the mirror. Look at the reflected ray. Mark the incident ray, normal and the reflected ray. Fold the paper which is beyond the edge of the cardboard. You will observe that the reflected ray is not seen in the folded portion of the cardboard. Now, bring the folded portion again to its original position. The reflected ray of light is again seen on the page. So, the conclusion, the sheet on the cardboard can be considered as a plane. The incident ray, reflected ray and the normal at the point of incidence should lie in the same plane. Then fill in the blanks. A person 1 centimeter in front of the plane mirror seems to be dash meter away from his image. From that person, from the object to the image, it's 2 centimeter. Okay, sorry, 2 meter. Then if you touch your left ear with the right hand in front of a plane mirror, it will be seen in the mirror that your right ear is touched by your left hand. The size of the pupil becomes larger when you see in dim light. When you see in dim light, the size of the pupil become larger so that more light will enter our eye. Okay, the size of the pupil will increase when you view in dim light because more light should enter our eye. If it is in bright light, then the size of the pupil will reduce or it will become smaller. Then night birds have lesser cones than rods in their eyes. Night birds have lesser cones than rods in their eye. Night birds have large cornea, more rods and less cones. Day birds have more cones and less rods. Then choose the correct answer, 7th one. The angle of incidence is equal to angle of reflection. Always. The angle of incidence is always equal to angle of reflection. Then 8th one. The image formed by a plane mirror is virtual, erect, behind the mirror and of the same size as the object. Then 9th one, the construction of a kaleidoscope. 10th one, draw the structure of the human eye. So, we will mark all these things in the textbook itself. Structure of kaleidoscope is given in page number 204, activity 16.6. Draw a label sketch of the human eye. The diagram is given in 206, figure 16.14. Then Gurmeet wanted to perform an activity with the help of a laser torch. Her teacher advised not to do so. Explain the reason for the teacher's advice. Laser beam is very harmful for her eyes. That may injure our retina. Okay, that may cause injure our retina. So, we will not be able to use, we should not use laser light. Okay, doing that experiment is activity 16.8. Okay. How can you take care of your eyes? That is given in page number 207. Then, what is the angle of incidence for a ray of light if the reflected ray is at an angle of 90 degree to the incident ray? If the reflected ray is at an angle of 90 degree to the incident ray, means I will draw the diagram here like this. This was his incident ray, this was the reflected ray. This angle is, I will draw the diagram here. This angle is 90 degree. That is the angle between incident ray and the reflected ray. That angle is 90 degree. So, what is the angle of incidence? So, if you draw this one is a normal, we know that angle I equal to angle R. Okay. So, angle I plus angle R equal to 90 degree. As per this question, the angle between incident ray and the reflected ray is 90 degree. So, angle I plus angle R equal to 90 degree. So, here angle I plus angle I equal to 90 degree or 2 angle I equal to 90 degree, angle I equal to 90 by 2, that is equal to 45 degree. Okay, that is equal to 45 degree. So, here the angle between incident ray and the normal is 90 degree. So, what is the angle of incidence? The angle of incidence will be 45 degree. The angle of incidence will be 45 degree. Now, how many images of a candle will be formed if it is placed between two parallel plane mirrors separated by 40 centimeter? The equation is n equal to 360 by 0 minus 1. So, if the angle between two parallel plane mirrors is 0 degree, so n equal to 360 by 0 minus 1, you will get the answer infinity. Infinity. Okay. However, first 2 or 3 images will be clearly visible and the other remaining images will not be visible clearly. Okay. Then 15th one, two mirrors meet at an angle, right angles. A ray of light is incident at one end of the angle 30 degree as shown in this figure, though the reflected ray from the second mirror. So, this angle is 30 degree, that is a question. This angle is 30 degree. The question is given like this. This angle is 30 degree, only this much is given. So, we will draw it. So, here this angle is also 30 degree. That angle is also 30 degree. Then this angle will be also 30 degree because it is alternate interior angles. This angle and this angle will be equal because it is alternate interior angles. So, this one is 90 degree. So, this angle will be 60 minus 30. 60 minus 30 that is 90 minus 30 that is equal to 60 degree. I will draw it here. This is a question. The angle between two mirrors are 90 degree. This is the normal and a ray of light incident at an angle 30 degree. This mirror A, this one is mirror B. So, this line will be reflected back and it will incident on this mirror B. So, the angle between these is 30 degree since angle of incidence is equal to angle of reflection. Now, this angle and this angle will be 30 same like this, two parallel, a transversal, so this line. Okay. So, this angle is 30 degree, that is this one. So, obviously this one also 30 degree. So, this one also 30 degree. Now, I will draw a normal here, this one is a normal. So, this angle is 90 degree. Angle between the normal and the reflecting surface is 90 degree. So, what is the angle of incidence here? This angle will be 60 degree. 90 minus 30, that will be 60 degree. So, the reflected ray will be like this. So, this angle is also 60 degree. Okay. So, that is the 15th question. Okay. Then 16th question and 17th question. Buju stands at the point A. Buju stands at the point A just on the side of the mirror of a plane mirror. Can he see himself in the mirror? Also, can he see the image of objects situated at P, Q and R? P, Q and R. Okay. So, he is standing at this point just on the side of the mirror. Buju cannot see himself on the mirror, but he can see the images of the objects placed at P and Q. Images placed at the objects placed at the point P and Q. He will be able to see the image of the object placed at P and Q, but he will not be able to see the image of an object placed at R, because here the reflected ray here is out of this mirror. Okay. So, he will not be able to see himself, but he will be able to see the image of the object placed at P and Q, but not on R. Then find out the position of the image of an object situated at A in a plane mirror. Can Buju at B see his image? Can Buju at C see this image? When Paheli moved from B to C, where does the image of A move? Okay. So, find out the position of the image of an object situated at A in a plane mirror. So, this is a question. So, here in this question only the diagrams is given like this. It is a plane mirror. This one is A, this is the point A, then this one is B and this one is C. Like a question is there. So, when you draw the diagram, when you draw the incident ray and the reflected ray with the help of a scale and a pencil, you will be able to see that the Paheli can see the image. Buju also can see the image of the object A. Okay. So, from this object the light ray incident on this mirror and it will be reflected. This one is the incident ray and it will be reflected to Paheli and it will be reflected to Buju also. So, they will be able to see the image of the object A. Now, when Paheli moved from B to C, where does the image of A move? Yeah, Paheli is moving from B to C. From B to C, Paheli is moving, but the image will not move. Image of the object will not move. If the image of the object will move, means we should change the position of the object. We should change the position of the object. So, here no change in the position of the object means the object is at A itself. So, there will not be any change in the image of the object A when Paheli moves from B to C. Okay. No change in the position of A, so the image will not move. Okay. Then, in this diagram, we will draw this with this a question. We will draw it with the help of a scale and pencil. Then, if the incident, the incident rays from this point A, the incident ray, here you can see the reflected ray reaches the point P and also at the point Q. So, he will be able to see the objects at P and Q, but he can't see the image, he can't see the object placed at R. Okay. He can't see the image of the object which is placed at R. This Buju can't see his image because the length of this mirror is very short. The length of the mirror is very short. So, Buju is not able to see his image on the mirror. Okay. So, you need to draw this diagram in your notebook. Okay. This diagram also you need to draw. Okay. Thank you.